Hello and welcome. What we're going to do here today is we're going to look at solving this system of equation with substitution and with elimination. We're going to do this to verify that either method works and that we get the same answer for both. Alright, so when we're doing substitution method, keep in mind what we're trying to do first is get an equation in terms of just one of our variables. So what that means is we're either going to want to choose our x or our y in either equation and get it alone. That's the first step of the substitution process. Now when I see this y right here, I see that it's not too far away from being by itself. And what we'll have to do to accomplish this is if we subtract 2x from both sides, our new equation will be that y is equal to a negative 2x plus 13. Now this is a key component of substitution because we're saying that this is what y is equal to. This is what allows us to substitute it into our other equation for y. So what that'll look like is this. We'll have 4x minus 3, but instead of the y, we are going to have what we said y was equal to. This is the process of substitution. So we'll put in a negative 2x plus 13, and all this is equal to a 1. So once we do this substitution process, now you may realize that our equation only has an x in it. That was the point. Now we will be able to solve for that x variable. Alright, we'll have to do this by first distributing. Now remember, to distribute a negative 3, don't forget this negative as we do our distributing process. So nothing's happened to our 4x here yet, but when we distribute, we'll get a positive 6x and a negative 39, and all this is equal to a 1. So for the next step, we're just going to continue on to solve. Now what we'll need to do is combine our like terms here. So we will have a 10x, and I'll also go ahead and add 39 to both sides. So we'll have a 10x is equal to a 40. Now once we divide both sides by 10, we will get that our x is equal to a 4. So we have half of our answer. Because not only do we need our x, we also need our y. So in the substitution process, and as well as in elimination, once we find one of our answers, we need to go back to our original equations, which I'll bring up here for us. We need to go back to our original equations, choose one of them, plug in the variable that we have found to find the missing one. So when I'm doing this, I'm going to want to pick the equation that's easiest to solve for y. It looks like it's going to be this first one here. Right, y isn't being multiplied by negative 3. This will offer me an easier path to my answer. So what I'm going to do is take this equation, but instead of x, I know that x is the 4, and this came from right there. Alright, so as we continue on here, we'll see that we have an 8 plus a y is equal to a 13. So once I subtract this 8 from both sides, we get that our x is equal to 4, and our y is equal to a 5. So we have just successfully solved this system of equation with substitution. Now we're going to do the same problem, except this time we're going to use elimination and verify that we do in fact get the same answer. Alright, so we'll keep that in mind, that x is equal to 4 and y is equal to 5. Here we go, draw the line. So now, I have our equations here, and we're going to use elimination. Elimination is where we're going to add our two equations up together in hopes that some of our variables will eliminate. Alright, so when I look at this equation right now, I don't see anything that will eliminate once I add our equations together. But I do see that these y's right here have the potential to easily cancel each other out. So what I'll do, and there are other options as well, but I'm going to take this first equation and I'm going to multiply it all by 3. And I do this, and I'll add it down here. Alright, and we'll distribute 6x plus a 3y is equal to a 39. This is a positive one, sorry. Alright. So once we have it like this, these are the two equations we'll add. Why did I multiply by this 3 in this step? So that now my y's will cancel each other out. So once I add these equations together, I'll get this 10x is once again equal to 40. Alright, so you may see we even get the exact same end result as we did on the last one. That's not always going to be the case, but it'll be something that does yield us this same x is equal to 4. Okay? Now, once we go back in to solve an equation for y, this is the exact same process that we did right up here above. I would be able to choose this equation here in red and plug in my x as a 4. So once we do that, we will get the same answer of y is equal to 5. So these methods have similar steps associated with them. It's just which one you want to do first. Are we going to want to multiply our equation both by a number here to have our variables be eliminated? Or will we be more comfortable with the first step involved in substitution, which is solving an equation for a variable like we did here, and then plugging it into the equation, distributing, and solving for our answer? Now in this example it was obvious that the substitution had more steps, but that's not always going to be the case. This video is just designed to show us that we do indeed get the same answer for both.